Okay, good morning, everyone. Today we are going to do two sessions with 3 units. First one is trigonometric. It is basic concepts. Then we will do vectors, and we are going to discuss unit and dimension tute. Okay, those are the 3 things we are going to do within today's class. Okay. Okay. Sorry. First thing, now we are going to discuss trigonometrics. It is about basic concept mein puta. So you have to write all the notes in basic concept book. Okay, basic concept book. Okay. Up to now, we have discussed about certain things about angles. Okay. First thing, we have defined angles. Okay. What is an angle? I need your response. Okay. What is an angle? What is an angle? I need your quick response. What is an angle? Everyone, I need your response. So I have defined the angle. So what is the definition of angle? What is the definition of angle? Angle is amount of rotation, no? Amount of rotation. Amount of rotation is measured by, is represented by angle. If you want to measure the amount of rotation around a certain point, we have to define a physical quantity. That physical quantity is the angle. Okay. According to that definition, you can clearly understand the angle can get infinite number of values. No, it is not limited to 180 degree or 360 degree. It is not limited, Kuta. Because according to the definition of angle, angle is the amount of rotation. Amount of rotation around a certain point. Around a certain point. So this rotation can get any value, no? Can get any value. So the value of angle is not limited to 180 degree or 360 degree. So it is not limited, Puta. It can get any value. So there may be infinite number of values for angles. Infinite number of values. It can get any value. So that is the basic definition, and it is the basic definition of the angle. Okay. Then we have defined the sorry, we have defined trigonometric ratios. There are 6 number of trigonometric ratios. So we have defined that using triangles. Using a right angle triangle. We have defined trigonometric ratios using right angle triangle. But if we define a trigonometric ratios using a triangle, it is limited to 180 degree, no? Because the addition of 3 angles of a triangle is equal to 180 degree. Is equal to 180 degree. So we cannot get any angle more than 180 degree using a triangle. Therefore, if we use a triangle to define trigonometric ratios, it is limited to 180 degree. So as there are infinite number of angles, we have to use another method. We have to use another some fair method to define trigonometric ratios. Now we are discussing about that. We are in the middle of that discussion. Now we are going to define trigonometric ratios in another way. Okay. Okay. Last time we have discussed about Cartesian coordinate. Still we did not define trigonometric ratios, but we have learned about Cartesian coordinate. There are 4 quadrants. We have defined that. What are those 4 quadrants? X. Suppose there is a Cartesian axis. There are 2 Cartesian axes, X and Y. So we call this plane as the Cartesian plane. Okay. In this Cartesian plane, wait a minute. In this Cartesian plane, this section is called as the first quadrant. This section is called as second quadrant. This part is called as third quadrant. This one is called as fourth quadrant. Those are the 4 quadrants in Cartesian plane. Okay. Actually, now we are going to define trigonometric ratios. Now we are in the middle of that. So before we define trigonometric ratios, we have to understand some basic concepts. The first one is Cartesian coordinate. So and we have to divide Cartesian coordinate into 4 quadrants. Those are the 4 quadrants. Okay. Do you have any questions up to now about quadrants? Did you understand this one? Thank you. Others?
Yes, sir.
Very good. Then we have learned about X and Y, sign of X and Y axis in each quadrant. As you know, in orders, if it is the origin, so this part of the x-axis, the right hand side of the x-axis is positive, and upward direction of the y-axis is also positive with respect to origin. And the left hand side and the downward direction of the y-axis with respect to origin is negative. The left hand side of the x-axis and the downward direction of the y-axis with respect to origin is negative. Therefore, if we consider the sign of x and y axes, you can clearly see if it is in the first quadrant, the x-axis is positive, y-axis is positive. If we consider the second quadrant, the x part is negative, y part is positive. If we consider third quadrant, x part is negative and y part also negative. If we consider the fourth quadrant, the y part is negative and x part is positive. So those are the signs of x and y axes in each quadrant. Okay. You should clearly understand about the Cartesian plane and the sine of x and y axes. Okay. Then after that we have defined projection, perpendicular projection of a line segment, perpendicular projection of a line segment on each axis. That means something like this. Suppose we are given A and AB line segment. Suppose we are given AB line segment and we need to find perpendicular projection of AB on x-axis. Suppose we are given AB line segment and we need to find the projection of AB on x-axis. How to do that? Can anyone tell me? How to get the projection of AB on x-axis? How to get that one? I need your response, Puta. How to get that done? භූතය ටිකක් දින්නේ මට. I need your response. How to get the perpendicular projection? How to get the perpendicular projection of AB on x-axis? Yes, Puta. Today is in English medium. My class, single medium class is scheduled on Wednesday. Every Wednesday, okay? Wednesday තියෙන්නේ single medium එක. English medium එක මේ Sunday තියෙන්නේ පුතේ. Okay. How to get the perpendicular projection of AB on x-axis? කොහොමද ගන්නේ? භූතය ටිකක් ඉන්නේ. කොහොමද ගන්නේ? In this case, we have to draw perpendiculars from each corners. From each corners to the x-axis. If we want to get the perpendicular projection of AB on x-axis, we have to draw perpendiculars from each ends to the x-axis. Okay. Two perpendiculars. Suppose AX, BX. So AX, BX is the perpendicular projection of AB on x-axis. Then, how to find perpendicular projection of AB on y-axis? Same method. We have to draw two perpendiculars. We have to draw two perpendiculars to the y-axis from each end of the line segment. Suppose AY and BY. So AY and BY are the points on y-axis. So sorry. If we draw two perpendiculars from each ends of this line segment to the y-axis, we will get the perpendicular projection of AB on y-axis. So that is the way of taking perpendicular projections of each axis. Okay, do you get my points up to now? So we stop here, no? We stop here.
Yes, sir.
Thank you. Others? We have I have given a note, no? I have given note on perpendicular projection, no? Can anyone tell me? මම perpendicular projection එකේ note එක දුන්නා නේද පුතේ? This is about trigonometrics, so you should written it on your basic mathematics book. Okay. මම මේකේ note එක දුන්නා නේද? මට ඒක පොඩ්ඩක් කියනවද? නැත්නම් note එකක් දෙන්න. Wait a minute. Okay. Then there's another definition. There's another definition before we define trigonometric ratios. We have to learn another definition that is about unit circle. Okay, write the topic. Today's topic: unit circle. Listen very carefully. Today's trigonometric lesson is very important lesson, Puta, because when you are doing calculations in mechanics, this part will be very important. Therefore, you should understand this part very clearly. So, listen very carefully. If you have any doubts, please let me know. Okay. Unit circle. Suppose there is a Cartesian plane. Okay. You know, this is the origin. This is the origin. So, if we draw a circle on Cartesian plane, something like this, okay? If the center of the plane, if the center of the circle is origin, if the center of that particular circle is origin, and the radius of that circle is unit 1 unit. Okay, 1 unit means 1 centimeter, 1 meter, 1 unit. Okay, 1 unit. I have drawn a circle. So what are the features of this circle? The center of the circle is origin, Puta. The center of circle is origin, and the radius is unit 1. Radius is equal to a unit length. Normally we call it as unit length. So this kind of circle is called as a unit circle. So what is a unit circle? If I draw a circle such that the center of the circle is the origin and the radius of the circle is a unit length. Such kind of circle is called as a unit circle. Unit circle. Suppose, so if we take this OA line segment, this OA line segment, suppose this OA line segment is inclined to the OX axis by theta angle. So if I rotate this OA axis, OA line segment, if I rotate this OA line segment around the origin, I can get any angle, no? I can get any angle because, so if I rotate this line segment by 360 degree, it comes to this position. So I can rotate this line segment by any amount. So from this line segment, I can create any amount of angle, any value of angle, any angle. I can create any angle from this line segment. Do you understand? Do you understand about that? Everyone, I need your response. Thank you. Others? Others? I need your response, because if anyone did not understand, I will explain that it again. Thank you.
So could you explain again, sir?
Okay, very good, very good. Unit circle. Unit circle is a circle that has a center, that has a center at the origin, and the radius of that circle is unit 1. Unit 1. You will understand why I use a unit circle later. Okay. But you should understand now what is a unit circle. What is a unit circle? Unit circle is the circle that has a center at the origin and the radius is equal to unit 1. Unit 1. Okay. Then suppose this one. If OA is a line segment, if OA is a line segment and it has an inclination, about theta angle to OX axis. Okay. So this theta is the amount of rotation of OA from OX axis, no? Suppose initially OA line segment was at this position. Suppose initially OA line segment was at this position, and if it is rotated by theta angle, the new position is this A1. So this theta means the amount of rotation of OA line segment from OX axis. Did you understand that one, Puta? This theta is the amount of rotation of OA line segment around O axis, no? Is it clear?
Yes, sir.
So if I rotate this OA axis, so if I rotate this OA line segment around O, if I rotate this OA line segment around O, I can create any angle, no? So if I stop here, then there will be a angle up this angle, no? If I may stop, if I stop this line segment here, I will have an angle more than 180, but lesser than 270. If I stop here, if I stop the line segment here, I will have an angle higher than 270 but lesser than 360. Did you understand that?
Yes, sir.
So I can create any angle by rotating this line segment. So this line segment can be used to create any angle. That means infinite number of angles. That's why I use a circle to define trigonometric ratios. I will explain how to define trigonometric ratios, but that is a reason. That is the reason of using a circle. That is the reason of using a circle to define trigonometric ratios, because I can create any angle using a circle. I can create any angle using a circle. Okay. Okay, write a topic. Write a topic. Unit circle. Unit circle. Okay. Write under this. Write another topic. Okay. Write another topic. After that, you can draw this sketch. Okay. Write another topic. As there are infinite number of angles, trigonometric ratios have to be defined for all angles. Write in another paragraph. We cannot use triangles. We cannot use triangles for this. We cannot use triangles for this. As we cannot obtain angles, more than 180 degree. More than 180 degree. Therefore, we are going to use a circle. We are going to use a circle. We are going to use a circle to define trigonometric ratios. To define trigonometric ratios. This circle is called as the unit circle. This circle is called as the unit circle. Oh, in another paragraph, the unit circle, the unit circle the unit circle is the circle, the unit circle is the circle, sorry, the unit circle is the circle with the center, at the origin, and the radius is unit 1. The radius is unit 1. Okay. Now you can draw this sketch. Before you draw this sketch, tell me this. I need your response, Puta. Actually, I need your response. So what is the Cartesian coordinate? What is the Cartesian coordinate of this point? What is the Cartesian coordinate of this point? Please tell me.
X0.
Yes.
X0.
No, not x0. X is 1, y is 0, Puta. X is 1, y is 0. X is 1, x-axis is 1, y-axis is 0. Therefore, this one is 1, 0. 1, 0, not 0, 1, 1, 0. Very good. Okay. Then, so what is the Cartesian coordinate of this point?
0, 1.
0, 1. Very good. This point?
1, 0.
Again, think. Very good. -1, Puta, because now it is towards the left hand side, from the origin. So it should be minus. So -1, 0. -1, 0. Very good. This one? This one? Yes. This one is 0, -1. 0, -1. Very good. Okay. Now you can draw the sketch. Okay. Okay. Now you can draw this sketch. Okay. Sorry. Have you completed this? Harde. Thank you. Others? Shall I erase the board? Okay. You can write under this sketch. So if we rotate OA line segment, if we rotate OA line segment around O, we can obtain any angle. Okay. Okay. Now we have completed the background knowledge before we defining the trigonometric ratios. Okay. Now we are going to define trigonometric ratios using a circle. Okay. Okay. Suppose this is the Cartesian plane and okay. Here we we have a unit circle around the origin. Okay. Then this is a line. Suppose, you know, this point A, this point A is on the perimeter of this unit circle. Okay. Suppose the Cartesian coordinate of A is x comma y. Cartesian coordinate of A is x comma y. If the Cartesian coordinate of A is x comma y, then sorry. Sorry. Okay. Now we are going to draw a perpendicular projection of A on x-axis. Perpendicular projection of A on x-axis. How to draw perpendicular projection? You have to draw a perpendicular. You have to draw a perpendicular from A puta. You have to draw a perpendicular from A. Here we don't have a perpendicular because O point is at the origin. So you don't want to draw a perpendicular. It is at the origin. So if we want to draw a perpendicular projection of A or A on x-axis, we have to draw a perpendicular from A to x-axis. Suppose this point is D. Then draw a perpendicular projection from A to y-axis 2. From y-axis D. Suppose it is E. Then tell me this. I need your response, okay? I need your response. Can anyone tell me about this distance? How much this distance? How much this OD distance? Can anyone tell me? OD distance. OD distance. OD distance. Yes, very good. Very good. Because of this point, you know the Cartesian coordinate of this point is x comma y. X comma y means the x coordinate of this point A is x puta. Then this length should be equal to x. The y coordinate of this point is y. That means this height should be equal to y. This height should be equal to y. So this length should be equal to x, and this height should be equal to y, because the Cartesian coordinate of A is x comma y. X comma y. You know, this is a rectangle, no? This is a rectangle. all the angles are in 90 degrees. So this might be a rectangle, or maybe a square, but might be a rectangle. So anyway, this is a parallelogram, no? So if it is y, then this side also y. This side also y. This side also y. I know this length. Suppose this length is r. I know this length is 1. Radius is equal to 1 because this is a unit circle. Okay. And you know these points, no? 1, 0. This point is 0, 1. This point is minus 1, 0. This point is 0, minus 1. Okay. Up to now, do you understand this about the diagram? How I may get this length? Do you understand? Everyone, I need to respond. If anyone, yes, thank you. Sorry. තේරුණාද කාට හරි ආයෙසරක් මේ කියා දෙන්න ඕනේද? කොහොමද ගත්තේ කියලා?
Understood, sir.
Thank you. Okay. Okay. Okay, then this is the unit circle. I assume OA line segment has rotated theta angle around point A, around point O. It has rotated theta angle around point O, and then then this point is the Cartesian coordinate of this point is equal to x comma y. That is my assumption. According to that assumption, I find some heights and length of this ODAE rectangle. Okay. Then we can go for the definition. How to define sine theta? How to define sine theta? Definition of sine theta is something like this. Okay. Actually, it is very equal to the definition of sine theta using triangle. But now we are going to define sine theta using the terms in unit circle. Okay. Sine theta defined as something like this. Perpendicular projection of, I will explain after may writing this, okay? Perpendicular projection of OA on y-axis over OA length. Look at this. Sine theta is defined as the perpendicular projection of OA, the perpendicular projection of OA on y-axis over OA length. Actually, we know the sine theta is equal to opposite side over hypotenuse, no? Opposite side over hypotenuse. So that definition is used here, in here. But in another terms, that is the only difference. Okay, Buddha? The same definition is not changed. The same definition, but we use some terms in unit circle to define sine theta. That is the only difference. You know, according to our basic definition, sine theta is equal to opposite side over hypotenuse. No, opposite side means y. Hypotenuse is equal to OA. Y over OA. We know that thing. No, opposite side over hypotenuse. We know that thing. But instead of writing opposite side over hypotenuse, now we are writing these terms using the terms of unit circle. So y is equal to this y. No, this y is equal to this y. That means the perpendicular projection of OA on y-axis. Perpendicular projection of OA on y-axis. That is the numerator. Then OA length means the hypotenuse. No, it is equal to hypotenuse actually. That's why we are writing OA length. But instead of writing opposite side over hypotenuse, now we are writing using terms of unit circle. Did you understand this one? Everyone, I need to respond. අද පොඩ්ඩක් කතා කරගන්න අමාරුයි. Thank you.
Yeah, understood, sir.
Okay. Then everyone you should understand this one, and you should remember this one. You should remember this one because this is the fair definition of sine theta, because we can use this definition to obtain sine value of any angle. Okay, that's why we should remember this definition: perpendicular projection of OA on y-axis over OA length. Now we can derive some expression for sine theta. Sine theta. Perpendicular projection of OA on y-axis. Perpendicular projection of OA on y-axis is equal to y, ne? Y puta. It is equal to y. OA length. How much the OA length? It is equal to 1, no? It is equal to 1. It is equal to 1 because this is a unit circle. This is a unit circle, so radius is equal to 1. So I can clearly write sine theta is equal y coordinate. Y coordinate. Very important theory, this one. Sine theta is equal to the y coordinate. So if you know the y coordinate of this point, that is equal to sine theta. That is equal to sine theta. So if you rotate this circle in any angle, if you rotate, if you want to find the sine theta, if you want to find the sine value of 540 or 620, any angle, then you have to rotate this OA line segment by 620 degrees. Once you rotate this line segment by 620 degrees, then you can take the y value, y coordinate of that particular point. That y coordinate is equal to sine value. Okay. Okay. Okay, Peter. Okay. Everyone, did you understand this one? I will explain. Please give me some time, okay? I will explain that. Okay. Write the topic. Define trigonometric ratios using unit circle. Okay. I will repeat that, Puta. I will repeat that. Okay. Please give me some time. Write a topic. Define trigonometric ratios using a unit circle. You can write this one. First one is this. Second, this one, and third one is this. Okay. I will explain that one. Okay. But පොඩි වෙලාවක් දෙන්න පොඩ්ඩක් අර කැස්සක් එනවා. Okay, everyone, look at the board again. I need your attention. Okay. Now we are going to define trigonometric ratios for all possible angles, because we can have infinite number of angles. Angles are defined as the rotation of the amount of rotation of the line segment. Therefore, amount of rotation can be get any value, so angles can be get any number of value. Therefore, there may be infinite number of angles. Therefore, this is a fair way to define trigonometric ratios. That's why we use a unit circle. Unit circle is the circle which has a center at the origin, and the radius is equal to unit 1. Radius is equal to unit 1. Okay. Okay. So now we are going to define sine theta value using unit circle. In this case, Puta, I assume this OA line segment has rotated theta angle with respect to OX axis. Now it has rotated theta angle. Okay. Then I have assumed all our assumptions. I have assumed the Cartesian coordinate of this point is x, y. Cartesian coordinate. Then I draw two perpendiculars. That means perpendicular projections. Perpendiculars mean perpendicular projections, no? Perpendiculars from A to x-axis and y-axis. As the Cartesian coordinate of point A is x, y, then this length should be equal to x. No? X. And this height should be equal to y. This height should be equal to y. I think up to that level you can understand, no? You can understand, no? Up to that level? Thank you. Then sine theta, the definition of sine theta, actually it is not a big deal. It is not a rocket science. Actually, we have used the same definition in triangles, no? In triangles, sine theta has defined the opposite side over hypotenuse. Opposite side over hypotenuse, no? Opposite side equal to y, hypotenuse equal to OA. So we use the same definition, but in another terms. Terms in circles. Some terms in circles. In the first case, we use the terms in triangles. Instead of triangles, now we are going to use these terms in circles. That is the only difference. That is the only difference. But the way of defining is same. Okay. Okay. How to define sine theta in terms of circles? Perpendicular projection. Y is the perpendicular projection. Y is the perpendicular projection of OA on y-axis. Y is the perpendicular projection of OA on y-axis. So instead of writing opposite side, I have written it as perpendicular projection of OA on y-axis. Then OA. Instead of writing hypotenuse, I can write this as OA length or radius. OA length or radius. Both are same. Okay. You can write it as radius. Okay. So now I have written sine theta, the same sine theta, but in this case, I have used terms in circles, not in not the terms of not the terms of triangles. That is the only difference. Okay, so if I use in terms of circle, it is equal to y perpendicular projection of y over OA length. So perpendicular projection of OA on y-axis is equal to y coordinate. So sine theta is equal to y over OA means 1, because I have used a unit circle. That means radius is equal to 1. So the denominator is equal to 1. So sine theta is equal to y. Sine theta is equal to y. So that means if you take any point on the circumference, any point on the circumference, any point on the unit circle, the y coordinate of that circle of the particular point, the y coordinate of the particular point represents the sine theta, sine value of the particular angle. That means something like this. Suppose this is a unit circle. If you rotate this OA line segment by 135 angle, by 135 degree. If you rotate it by 135 degree, then it will stop here. So the y coordinate of this point is equal to sine theta. Suppose this is a unit circle. You have rotated this line segment, this line segment by 240. Suppose 240 is in third corner. 240 degree. If you rotate the line segment by 240 degree, that means this y coordinate of this point represent the sine value of this angle, sine value of this rotated angle. Did you understand? Everyone? Thank you. Others? Because this definition, Puta, according to this definition, the sine value of rotated angle, look at this, theta is the rotated angle. Puta. Theta is the rotated angle. Sine theta means sine value of the rotated angle. So the sine value of the rotated angle is equal to the y coordinate. It's y coordinate. So if I rotate this rod by 240 degree and comes to this point, that means the y coordinate of that point is equal to the rotated sine value of the rotated angle. There others? History? Thank you. Okay, Pata. Okay, then you can write this. You can write this paragraph after your drawing. Suppose the OA line segment has rotated, has been rotated. The OA line segment has been rotated by theta degree around the point O, around the point O. Around the point O. Assume the Cartesian coordinate of A, the Cartesian coordinate of point A is x comma y. X comma y within the brackets, okay? So you may assume the Cartesian coordinate of the point A is x comma y. X comma y. In another paragraph, we can define trigonometric ratios of theta. Trigonometric ratios of theta angle. We can define trigonometric ratios of theta angle using the terms in circles. Using the terms in circles, using the terms in circles instead of the terms in triangles. The terms in triangles. That we can instead of terms of triangles. instead of terms in triangles. Terms in triangles.
Sir,
Also,
it's a small question, sir.
yeah.
So why do we take the radius as 1? Is there a particular reason? No.
I will explain, Buddha. I will explain that one. Okay?
Okay.
I will explain that one, Buddha.
Okay, sir.
Okay. Then, in another paragraph, this is the only difference. This is the only difference. This is the only difference between the previous definition and the above definition. Between the previous definition and the above definition. Okay. You can use your previous drawing, Buddha. Now I am going to define cos theta. Now I am going to define cos theta. You can use your previous drawing. Okay. Look at this. I have to draw a perpendicular projection from A to the x-axis. This is D, no? I cannot remember D, no? This is C. So this length is Y and this length is X. Okay. Sin theta is defined as the ratio between the perpendicular projection of y-axis over OA. Likewise, the cos theta is defined as the ratio between the perpendicular projection of OA on x-axis over OA length. Okay. As you already know, how to define cos theta using triangle? How to define cos theta using triangle, Puta? It is equal to the adjacent side over hypotenuse. No, adjacent side over hypotenuse. So adjacent side is equal to OD, hypotenuse is equal to OA. Now I have to write those length in terms of circle. No? So I have to replace those words using terms in circles. OD is the perpendicular projection of OA, Puta. Okay. Therefore, I can write that word. What is that word? Perpendicular projection of OA on x-axis instead of the adjacent side. Okay. Instead of adjacent side, I can write the perpendicular projection of OA on x-axis. So it is equal to the perpendicular projection. Perpendicular projection perpendicular projection of OA on x-axis over OA. If I use a triangle, so I have to write it as the hypotenuse, no, hypotenuse. But instead of hypotenuse, I can write it as in circles term, no, in terms of circle. OA is equal to radius, or just write OA length or radius. OA length or radius. Then cos theta. So cos theta is equal perpendicular projection of OA on x-axis means this length, OD length, that means x. In another terms, it is equal to the adjacent side, no? Adjacent side. Over OA length. OA length means this is this one. This one. 1. It is equal to 1 because this is a unit circle. This is unit circle. Okay. So according to that, cos theta is equal to x. Cos theta is equal to x coordinate of the particular point. X coordinate of the particular point. That means if I rotate this line segment by theta angle and come to this point, the x coordinate of this point is represented the cos value of that angle, particular angle, and y coordinate of that certain point represents the sine value of that particular angle. Do you understand this one? I will explain why I use a unit circle for this one. Up to now, do you understand? Everyone, I need you to respond. Thank you. Others? Thank you. Okay. Okay, Putta. That is the definition. That is the definition according to once I use a unit circle to define sine theta and cos theta, actually cos theta is equal to the x coordinate of x coordinate, and sine theta is equal to y coordinate of any point on the circumference of the unit circle. Okay.
So when you say perpendicular projection of OA on x-axis, shouldn't it be y? Because like perpendicular projection of OA on x-axis is y, sir.
No. The perpendicular projection is this one. How to define a perpendicular projection? Suppose this is a line segment. Perpendicular projection is, suppose if I incident a parallel light beam, from here on this line segment. Suppose this line segment is AB. So if I incident a parallel light beam on this AB line segment from the upper direction, then the shadow on x-axis is called as the perpendicular projection of that particular line. Okay. So what should I do? I should incident a parallel light beam on this line segment. I should incident a parallel light beam on this rod. Okay. If I incident a parallel light beam here, you can clearly see from here light may pass no. Hmm? Hmm? From here light can pass in this region, no. But if you consider this region, light cannot be passed, no. That means in between this region, between this region, light cannot be passed through this rod. So the shadow of this rod on x-axis should be laid in between these points. Did you understand?
Thank you so much, sir.
So that is the definition of the perpendicular projection. So perpendicular projection is once we incident light beam from here, from upward direction, then we can get the perpendicular projection of a certain line segment on x-axis. If we want to find the perpendicular projection of certain line segment on y-axis, you have to incident light beam from here, from right hand side, from here. If we want to find the perpendicular projection of a line segment on y-axis, you have to incident a light beam from here, perpendicular, so parallel light beam. Okay, nikan light beam ane parallel light beam ka. You have to incident a parallel light beam from here. Then you can clearly see the points below point A. The light can pass very easily, no? Light can pass very easily. The points above point B, light can pass very easily. But in between these two, that means in between these two, light cannot pass through this rod. Light cannot pass through this rod. That means the shadow of this rod on y-axis should be in between these two lines. That's why we draw two perpendiculars to identify the shadow. Do you understand that?
Yes, sir.
Others? So that is the meaning of perpendicular projection, Puta. In this case, we don't want to draw a perpendicular from O, because O is at the origin. No? We cannot draw a perpendicular from O. Therefore, if you want to find the perpendicular projection of OA, just draw a perpendicular from A. Just draw a perpendicular from A. Okay. Then perpendicular projection is equal to this one. Okay. Did you understand? Everyone? I need to respond. Did you understand? Okay. Then you can write the definition of cos theta. You can write definition of cos theta. Then write this one and this one and this one. Okay. Have you completed this one? Have you completed? Okay. Others? Okay, I will give some time. Thank you, Pata. Others?
1 second, sir.
Okay. Shall I erase now?
Okay, sir.
Okay. Okay, Pata. Now I will explain why I use a unit circle instead of any radius. Okay. Suppose I have drawn a circle larger than unit circle. Okay. Larger than unit circle. Then I have to extend this one up to here, no? No? So if the rotation is theta, if the rotation is equal to theta, then this position won't be changed, no? If the rotation is theta, this position won't be changed. So I have to extend OA line segment up to A dash. No? Do you understand, Putta? If I use a large circle, and if I want to find the rotation of theta, I have to rotate OA dash line segment from OX to A dash, no? Tell me other. If I use a large circle, if the rotation is same, then this OA, this radius should be in this line, OA, A dash line. Suppose this one. Don't draw any circle, okay? Don't draw any circle. Suppose there is a line, there is a line. You have to rotate that line around O axis by theta degree. Now you have rotated this line. You have rotated this line around point O by theta degree. Suppose this line has a length, infinite length. Suppose this line has infinite length. Okay. Then you can draw any circle around this, no? You can draw any number of circle around this, no? Do you understand? Do you understand? So unit circle is actually it doesn't matter. It doesn't matter. You can use any circle. You can use any circle, but the definition won't be changed. Then, if you use a circle that has a radius 2 centimeter, then what would be the definition? The same definition. The projection of OA on x-axis over OA length or radius. Then you have to use the radius of your circle instead of 1. That is the only difference. You can use any circle to define trigonometric ratios. You know, not only unit circle. You can use a circle with any radius, because this angle won't be changed. You can draw any circle. You can draw a circle with any radius. Okay, this angle won't be changed. You know? Everyone, I need your response. Okay. Therefore, unit circle doesn't matter. Actually, it doesn't matter. You can use any circle. But there should be a standard, no buta. There should be a standard. The standard definition is using a unit circle. That is the thing. Okay, that is the thing. Because if I want to draw a 2 centimeter circle, and I can define trigonometric functions using 2 centimeter circle. Imagine you need to draw 3 centimeter circle, and imagine you need to draw a 3 centimeter circle and define trigonometric ratios. And someone can draw a 4 centimeter circle and define trigonometric ratios. So actually there should be a standard, no? The standard circle is the unit circle. That is the only matter. That is the only thing. Instead of unit circle, you can use any circle to define trigonometric ratios. But if you use a particular circle, then you have to define trigonometric ratios according to that circle. That is the only difference. Do you understand, Puta? තේරුණාද question එක අහපු? Okay පුතේ. Okay, actually we can use a circle with any radius to define trigonometric ratios, but the standard is unit circle. That is the only reason to use unit circle to define trigonometric ratios. That is the only reason. ඒක තමයි එකම හේතුව unit circle එක මම use කරන්නේ. හරි. නැත්නම් unit circle එක නැතුව පුතේ ඕනි circle එකක් ගන්න පුළුවන්. නමුත් ප්‍රශ්නේ තියෙන්නේ ඕනි circle එකක් ගත්තොත් අර OA length එක එයාගේ radius එක වෙනවා. එච්චරයි. එතකොට radius එක අපිට දාන්න වෙනවා. එතකොට calculation එක පොඩ්ඩක් difficult වෙනවා. එච්චරම තමයි. Okay. Unit circle, if you use unit circle, your calculations will be very easy because radius, the value of radius is 1. Value of radius is 1. That is the thing. Okay. So if we use a unit circle to define if we use a unit circle to define trigonometric ratios, you can clearly understand y coordinate. Y coordinate is equal to sine theta and x coordinate is equal to cos theta. So normally, due to that reason, we define x-axis as cos axis and y-axis as sine axis. Y-axis as sine axis because of that reason. Because of that reason. This definition is very easy to remember because we are going to remember a lot of angles. Okay, Buta? The sine values and cos values of lot of angles, tan values of lot of angles. Okay. Therefore, it is not very, it won't be very easy. You cannot remember all the angles, no? But you have to remember the definition. You have to understand the definition, how we define that trigonometric ratios. Once you understand this, then you can derive any angle without remembering anything. ඒකයි කියන්නේ මතක තියාගන්න ඕනේ නැහැ. වද වෙන්නේ නැතුව ටක් ගාලා ඩිෆයින් කරගන්න පුළුවන් මේකත් හරියට තේරුම් ගත්තොත්. හරි? හොඳයි. හොඳට මතක තියාගන්න මම කියන දේ හොඳට තේරුම් ගන්න. හරි? මොකක් හරි ප්‍රශ්නයක් තියෙනවා නම් අහන්න පුතේ. Okay. Now we have defined up to sin theta and cos theta. Tan theta. Tan theta is defined as the ratio between sine and cos. Sine and cos. That is the definition of sine and tan theta. Okay. Tan theta is defined as the ratio between sine theta and cos theta. We have learned this relationship, Puta. We have learned this relationship. We can prove this relationship using triangles. Therefore, I'm not going to repeat that again. We have learned this relationship. Okay. So this relationship is used to define tan theta in this case. Okay. Tan theta is defined as the ratio between sine theta and cos theta. Okay. Sine theta is equal to y-axis and cos theta is equal to x-axis. Okay. Therefore, sine theta is equal to y over x. Y over x. This is the definition of tan theta. This is the definition of tan theta. Tan theta is defined as sine theta over cos theta. Sine theta over cos theta means y over x. Okay. This relationship has been proven in our previous class. Okay, Buta? Therefore, it is not, I'm not going to prove this again. Okay. Then, after you completing the previous writing, you can write the definition of sine theta, definition of tan theta. Then, this is the definition. This is the definition of tan theta. Okay. Up to now, do you have any question? Did you understand up to now? How I define sine theta and cos theta and tan theta? Thank you. Others? Did you understand up to now? I need you to respond, Puta. Others? Thank you. Thank you, Puta. Okay. Okay. Okay, I will explain, Puta. I will explain. Okay. 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 I'm not going to draw the unit circle. I'm not going to draw the unit circle. This is O, A, D, and E. You can use the same drawing. So this is X and Y coordinate. So this height is Y. This length is X. This length is X. You know, according to our previous definition, sine theta is equal to X. Sorry, what? Number one. Cos theta is equal to X. Number two. This is 1 and 2. Okay. I will explain this again. Okay. Actually, we have done this part puta. Now, this is again, I will explain that one. Okay. Sine theta is equal to Y. Cos theta is equal to X. Okay. According to our previous definition. Then, look at this. According to OAD, according to OA triangle, I can write an expression for tan theta. Tan theta is equal to opposite side over adjacent side. Opposite side over adjacent side. That means AD over OD, no? AD over OD. AD over OD. That means Y over X. AD means Y, OD means X. Y over X. Okay. That's why tan theta is equal Y over X. That means sine theta over cos theta. Therefore, tan theta is equal to Y over X. That means Y is sine theta, cos is cos theta. Y over X. That means sine theta over cos theta. Okay. Did you understand? Everyone? I skipped this part. Okay, I skipped this part because we have done this previously. Anyone want to explain again? Okay. This is the way of deriving sine theta, tan theta is equal to sine theta over cos theta. Okay, Puti? මේ definition එක නම් මතක තියාගන්න ඕනේ කියලා කියන්නේ හැම වෙලේම use වෙන definition එකක් අපිට especially in mechanics. So the tan theta is equal to sin theta over cos theta කියන එක. හරිද? sin theta over cos theta කියන definition එක. Very important definition එකක්. So if anyone miss this part, you can draw this diagram. No, you can actually use your previous diagram and write this one. Sin theta is Y, cos theta is X. And according to this triangle, tan theta is equal to opposite side over adjacent side. That means Y over X. Y over X means sin theta over cos theta. හොඳයි. ඉවරද දීලා? Okay. Up to now, do you have any question? Do you want any clarification? If you want any clarification, I will explain that one, okay? Because this trigonometric part is very important trigonometric part, because without this part we cannot do mechanics actually. Everyone, I need your response. Did you understand up to now? Okay. Thank you, Buddha. Hari. Okay. Our definition, according to our definitions using unit circle, the x coordinate is equal to cos value and y coordinate is equal to y value. Therefore, normally we have we can define x axis as the cos axis and y axis as the sin axis. This is very important part, Puta. Nominating x axis as cos and y axis as sin. This is very important part, because from this we can easily get values of any theta, any angles, sin value and cos value of any angles. Okay, defining x-axis as cos axis and sin axis as y-axis. Okay, so write down a note, a special note. Write down a special note. You can draw this. Right under this. If we consider a point, on a unit circle, if we consider a point on the unit circle, the x coordinate of that point, the x coordinate of that point is equal to the x, to the cos value of particular angle. Another paragraph. The y value of the y coordinates, the y coordinates of that point, the y coordinate of that point represents the sine value of the particular angle. The sine value of the particular angle. Therefore, x-axis is called as the cos axis. Therefore, the x-axis is called as the x-axis. Sorry, the x-axis is called as cos axis. Therefore, the x-axis is called as the cos axis and y-axis is called as the sine axis. Okay. Okay. If you have any questions up to now, if you have any question, මම මේ හැම වෙලෙම questions තියෙනවද කියලා අහන්නේ පුතේ. මොකද ඔයගොල්ලන්ගේ මොකක් හරි doubt එකක් තියෙනවා නම් ඒ වෙලෙම clear කරගෙන යන්න. මොකද මේක ආම important lesson එකක් මේ trigonometric කියලා කියන්නේ මේ lesson එක. මේ trigonometric විතරක් නෙමෙයි ඊටු හැම lesson එකෙම මොකක් හරි doubt එකක් තියෙනවා නම් අනිවාර්යෙන් ඒ වෙලෙම clear කරගෙන යන්න. හරි. මොකද දැන් අපි ඊළඟ මේ next week එකේ අපි ඔය trigonometric වල ඕනිම මේ angle එක trigonometric ratios හොයන හැටි කතා කරනවා. එතකොට මේ definition එක මාරම විදියට මේ important මේක මේ ඔයගොල්ලෝ හරියටම ඒ කියන්නේ ඔයගොල්ලන්ගේ කිසිම doubt එකක් නැතුව ඔයගොල්ලන් හරියටම well understand වෙලා ඉන්න එක මාරම important. හොඳයි. හොඳයි. So do you have any doubt? Now it's time. Okay. No doubts. Doubts නැද්ද? Okay. මුච් දෙයක් කියන්න තියෙනවා. ඒ තමයි next week එකේ පුතේ class එක මට පොඩි මේ ඒ කියන්නේ ගමනක් යන්න වෙලා මේ තියන්න වෙන්නේ නැහැ. මම ඒකට මේ week එකේ week දෙකක් මම ඔයගොල්ලන්ගෙන් ගන්න ඕනේ. මට Monday පුළුවන්. කියන්නේ හෙටත් පුළුවන්. Tomorrow after 4 o'clock මට පුළුවන් කියන්නේ මේ instead of Sunday class. Okay. Sunday class එක මට තියන්න වෙන exam එක පුතේ 20 මේ next week එකේ මේ එන්නේ next week මේ තියමු exam එක මේ week එකේ Monday evening මට පුළුවන් ඒ කියන්නේ හෙට evening පුළුවන් මට අරකට වෙනුවට class එක කරන්න හරිද හෙට after 4 o'clock anytime ඔයගලන්ට පුළුවන්ද කොහොමද කට්ටියගේ නැත්තම් ආයි Friday arrange කරගන්න පුළුවන් Friday ඉතින් after 4 o'clock පුළුවන් Friday or Monday okay Monday can no okay Friday Monday okay I will send a poll okay then we I think okay if you want I can do the class on both days okay it's no matter because your exam is on next not this week 21st no 21st or 22nd Sunday exam එක ටිකක් okay thank you පුතා 22nd no 22nd පුතා මොකද අතරම මේ දැන් අපි මේ අලුතෙන් join වෙච්ච ළමයි ඉන්නවා මේ සිංහල medium ඉංග්‍රීසි medium දෙකටම ඒක නිසා chance එකක් දෙන්න ඕනි පරණ recordings බලන්න ඒගොල්ලන්ට පරණ recordings බලලා පුතේ අනිවාර්යෙන් ඒවැ අපි කොහොමද මේ classes වල ඒ questions හැදුවේ ඊළඟට කොහොමද අපි duty වල questions කරේ කියලා අනිවාර්යෙන් මේ බලා ගන්න මේ time එක තියෙනවා exam එක tough ආයෙ මම මුත් කියන්නේ ඒ කියන්නේ මේ ඕලන්ට බුරුල් දෙන්න බෑ හොඳේ tough හොඳේ unit 1 2 hour MCQ paper එකක් තියෙන්නේ 2 hour MCQ paper එකක් plus 1 hour or half an hour මම ඒක තව decide කරේ නැහැ time එක essay paper එක හරි ඒක essay paper එකේ තියෙන difficulty එකත් එක්ක මම time එක define කරන්නම් 2 hour MCQ paper එක අනිවාර්යෙන් තියෙනවා 2 hour MCQ paper එක ඒක යන්නේ ඔයගලන්ට මම Google form එකක් එවනවා Google form එක timely කරන්න වෙනවා මොකද ඒක open වෙන්නේ සහ close වෙන්නේ පුතේ time එකේ එතකොට within that time කරන්න වෙනවා ඊට පස්සේ submit කරන්න බෑ ඊට පස්සේ submit කරන්න බෑ ඒක නිසා කොහොමත් මම 2 hour තියෙන එක මම 2 hour and plus 10 minutes විතර මම දෙනවා කොහොමත් ඔය logging වෙන ප්‍රශ්න ඊට පස්සේ යනම් මම ළමයිට තියෙන නිසා මේ ඒක නිසා 2 hour ම ගන්නට මම limit කරන්නේ නැහැ එතකොට ඒක submit කරන්න වෙනවා ඒ කියන්නේ එතනින් එහාට ඒක respond දෙන්න බැරි වෙනවා ඒක නිසා timely කරන්න ඊළඟට වෙන කිසිම දෙයක් නෑ කරපුවම තමයි කරපුවා කියලා කියන්නේ මේ කරපුවම යහන්නේ මේ තේරුම් නෑනේ මේ ඒ විදිහම questions තමයි තියෙන්නේ ඒක නිසා හොඳට ආයෙ recordings බලාගෙන මොකක් හරි exam එක කාලෙම මොකක් හරි මේ clarifications එකක් කරගන්න තියෙනවා නම් මම ඒක අහගන්න හරිද හැමෝටම මම මේ කියන්නේ මොකක් හරි clarification එකක් තියෙනවා නම් මොකක් හරි question එකක කරගන්න මම ඕගොල්ලන්ට MCQ paper එකක් දීලා තියෙනවා එතන questions මම මට මතක විදිහට questions 110 වගේ තියෙනවා මේ if you complete these questions then you can do the exam without any failure okay MCQ questions MCQ paper consists of 60 MCQs 60 50 MCQs 50 MCQs so that 50 MCQ should be completed within 2 hours okay පුතේ 50 MCQ ඒ කියන්නේ exam එක වගේම තමයි A-level exam එක වගේම තමයි 50 MCQs තියෙනවා within 2 hours complete කරන්න ඕන හරි so you have to complete those questions within 2 hours I think it is better to do our tute first if you do the tube first, then it will be much easy to do that exam. Okay. exam එකට මම මේ දැන් කියන්නේ recordings බලන පුතාලා ඉන්නවා, recordings බලන කට්ටිය ඉන්නවා, කට්ටියම එකට මේ එන්න කියනවා. හරිද? recording බලන කකාගේ හරි මොකක් හරි special request එකක් තියෙනවා නම් මොකක් හරි වෙන time එකක කරන්න මට ඒක පොඩ්ඩක් මේ in advance කියන්න. එතකොට මේ අදාළ දරුවට මට දෙන්න පුළුවන් වෙනම time එකක exam එක. එතකොට exam time එකේ වෙනසක් නැහැ, form එකේ වෙනසක් නැහැ. හැබැයි questions අපල කරන්න පුළුවන්. මේ හරියටම කරන්න ඕන නිසා ඒක නිසා හොඳට මතක තියාගන්න exams ටික මේ කවුරු හරි recording බලන දුවෙක් හරි පුතෙක් හරි ඉන්නවා නම් ඒ කියන්නේ Sunday ওই time එකට join වෙන්න බැරි අනිවාර්යෙන් මට in advance කියන්න. in advance කියන්න. මේ එතකොට 22nd තියෙන class එකේදී අපි එක කරන්නේ. මේ ඒක නිසා අනිවාර්යෙන් මතක තියාගන්න එතන in advance කියන්න. ඒක මේ ඔය එන කට්ටිය මට වෙනම මම ඒක මම දාන්න කරන්න ඕන විදිය මම දාන්නම් මේ කොහොමද කරන්න කියලා. මොකද මේ මම group එකට ඒක share වෙන්නේ නැහැ. එන ළමයිට මම මේ link එක වෙනම එවන්නේ. ඒ නිසා මම ඒක කොහොමද කරන්නේ කියලා මම group එකේ instruction එක දෙන්නම් කොහොමද කරන්නේ කියලා පුතාලා. මේ ඒ අතරේ මොකක් හරි ඔය doubts එකක් තියෙනවා නම් questionable තැන් තියෙනවා නම් මගෙන් අනිවාර්යෙන් clear කරගන්න. ඊට කලින්. මොකද දැන් ඕගොල්ලන්ට 2 weeks තියෙනවා. 2 weeks තියෙනවා. 2 weeks කියන හොද්දටම ඇති. ඒක නිසා මම ඒ කියන්නේ අනිවාර්යෙන් ඕගොල්ලෝ ඒක හරියට well prepared වෙලා කරයි කියලා බලාපොරොත්තු වෙනවා. ඒ නිසා කරන්නම් වාලේ කරන්න එපා. කරන්නම් වාලේ කරන්න එපා. මේක මේ මම හැම වෙලෙම කියන්නේ එකයි. හැමෝටම කියන්නේ එකයි කරන්නම් වාලේ කරන්න එපා. Now you have 2 weeks. So may do our tudes and you can follow the previous lessons as well. Therefore, if you have any things to clear, any question to ask, please clear those things before the exam. Okay. When you're doing the tudes, you maybe have a lot of questions. So if you cannot solve those questions, please let me know. Okay. That is the best way. Okay. හරි. එහෙම වුණොත් okay. පොඩි break එකක් ගමු. පොඩි break එකක් කරන් 10 minutes break එකක් අරගන්න. 10 minutes break එකක් අරගෙන 10:35 ආයි එන්න. leave වෙන්න ඕනෙත් නෑ. ඕනනම් මම තිබ්බට කමක් නෑ. 10 minutes break එකක් අරගෙන ආයි මෙතන මේ ආයි එන්න 10:35. හරියටම 10:35 එන්න. හරි? Okay. Now you can get a 10 minutes break, Puta, 10 minutes break, and please join again 10:35 exactly 10:35. Okay. Meanwhile, if you have any question, I'll be there. Okay. Okay, Puta. Okay. Can you hear me? Can you hear me? Thank you. Okay. Now we are going to start vector section. So you have to note down this in your vector mechanics book. Okay. Mechanics book. Okay. Up to now we have defined what is a vector, and we have learned about some special vectors, no? we have defined what is a vector. Then we have learned about some differences between vector quantities and scalar quantities. Then we have defined the magnitude of a vector. After that, we have learned some special vector, null vector, equal negative vector, and we have discussed about equality of vector. Okay. If if there are two vectors with same direction and same magnitude, then those two vectors will be equal to each other. Okay, equal to each other. To have equal vectors, both should have same magnitude, should have same arrowhead direction. Okay, that means both should parallel to each other. Then the magnitude should be equal. Okay, those kind of things we have discussed up to now. Okay. Okay. Now we are going to do some exercise. Actually, we have done some exercise regarding negative vectors and equal vectors. No, in that case, we have choose some negative vectors. What are the negative vectors? Among the given vectors, then we have done such kind of question. No, wait a minute. Okay. Today we are going to discuss. About some question type. What are in this section? In this section, we are going to discuss if we are given some vector. And we are asked to find some another vector using that vector. That means something like this. Suppose AB CD is a triangle square. Suppose ABCD is a square. Then we are given the value of AB vector. Suppose the value of AB, the magnitude of AB vector is equal to 10 Newton. 10 Newton or something. Okay. If we are given a vector system and the magnitude of one vector may some few vectors, and we are asked to find some certain vector in that vector system. In this case, we have to use our geometrical knowledge to find this value. Suppose something like this. You are given ABCD is a square, and the magnitude of AB vector, is equal to 10 Newton. Suppose you are given ABCD is a square and the magnitude of the AB vector is 10 Newton. Then you are asked to find the magnitude of DC vector. How to find that one? Wait a minute. How to find that one? Please give me answers. The magnitude of DC vector. How much? Good. Very good. Wallah, correct. 10 Newton, no? In this case, you have used your geometrical knowledge. You know the length of AB and length of DC is the DC are equal. That means the magnitude of AB vector and the magnitude of DC vector are equal. Therefore, the magnitude of DC vector is equal to 10 Newton too. No? This kind of things you can you will have in your exam. Okay, in exam, or actually when you are doing mechanics, you have to have this knowledge. Okay, if you are given some vector, then you have to use the magnitude of that vector to determine the magnitude of another vector. No, actually not equal vector, puta, but this is a square, no, puta. This is a square. Therefore, the length of AB is equal to length of AC. The length of AC. DC, sorry, DC. Then another question. Find the magnitude of AC vector. Find the magnitude of AC vector. How to find the magnitude of AC vector using this data? Then you will have the answer for that question. How to find the magnitude of AC vector using this data? Yes, Pythagoras theorem. Okay, you can get the answer. So if it is a vector system, puta, if it is a vector system, you know, I can represent the magnitude of vector using the length of this line segment. No, I can represent the magnitude of vector using the length of this line segment. So if the magnitude of AB vector is 10 Newton, that means this line segment equal to 10 Newton. This line segment is equal to 10 Newton. So DC line segment is equal to AB line segment. The length are equal. That means DC vector, the magnitude of DC vector should be equal to 10 Newton too. Okay. That is the logic behind that, puta. Do you understand that? Thank you. Then, as this is a square, then we can write this vector is also equal to 10 Newton. Is also equal to 10 Newton because actually the magnitude of that vector, this BC vector is also equal to 10 Newton. Magnitude of BC vector is also equal to 10 Newton because AB equal BC. AB equal BC. And the AB represents 10 Newton. That means BC should be represent 10 Newton too. Okay. We can write it as follows. AB length is equal 10 Newton. AB length is equal 10 Newton. No? Therefore, I can write AB length equal BC length. Therefore, BC length should be equal to 10 Newton too. It should be equal to 10 Newton too. Okay. Then we can find the length of AC. We can find the length of AC using Pythagoras theorem. So, how much the length of AC? AC squared is equal. Not AC squared. How much the length of AC? You can use your mind and tell me the answer. How much the length of AC? Do not do any rough works. Do not do any rough works. How much the length of AC? Go. Then another word. Use your mind and calculate within your mind how much the length of AC, the length of AC, the length of AC. Square root of 200, yes, that is correct, but I want to simplify the answer. Simplify the answer. What is the simplified answer? The square root of 200 means 10 times root 2, no? 10 times root 2, no? 10 times root 2, no? Okay, I will explain how I get this answer. හැබැයි ඊට කලින් මට පොඩි දෙයක් කියන්න. ඊට කලින් පොඩි දෙයක් කියන්න. මේක පටන් ගත්ත එක හොඳයි. මේ කතන්දරේ. මොකද්ද? අපි මයින්ඩ් එක යූස් කරන එක. මයින්ඩ් එක යූස් කරන එක. මට කියන්න දැන් ඕගොල්ලෝ ඒලෝ කරන්න ඇවිල්ලා තියෙන්නේ. ඒලෝ කරන්න ඇවිල්ලා තියෙන්නේ ඕගොල්ලෝ සයන්ස් ස්ට්‍රීම් එක සිලෙක්ට් කරලා තියෙන. සයන්ස් කියන්නේ මැත්ස් වේවා, බයෝ වේවා, සයන්ස් ස්ට්‍රීම් එක සිලෙක්ට් කරලා තියෙන. හරිද? මම මේක මං හිතන්නේ මීට කලින් කියලා තියෙන පුතේ. හොඳට අහගන්න. හොඳට මේක ඕගොල්ලෝ මේක තේරුම් ගන්න මේකේ තියෙන මේ ඇත්තම කතන්දරේ. හරිද? සයන්ස් ස්ට්‍රීම් එක ගත්තොත් සයන්ස් ස්ට්‍රීම් එකේ සාමාන්‍යයෙන් පාස් පර්සන්ටේජ් එක දන්නවද? පාස් පර්සන්ටේජ් එක. කියන බං චෙක් බොක්ස් එකේ. normally pass percentage. normally body fluctuation එකක් තියෙනවා. නමුත් ඒක right. body fluctuation එකක් තියෙනවා. නමුත් normally 50%. 50%. That means 50% students will be failed. Fail. ඒක බොහොම භයානක කතාවක්. මම මේගොල්ලෝ බය කරනවා නෙවෙයි. ඔයගොල්ලෝ බය කරනවා නෙවෙයි. මම මේ කියන්නේ ඇත්ත කතන්දරේ. මේ මම මේ ඔයගොල්ලන්ට කියන්නේ පුතේ මේකෙන් කොහොමද ඔයගොල්ලෝ ඕවර්කම් කරන්න කියන දේ. හරිද? මොකද ඕවර්කම් කරන්න අපි උගන්වන්න එපා. මේක ඕවර්කම් කරන්න උගන්වන්න නැතුව තේරුමක් නැහැ. හරි? ඇයි මේ 50% ෆේල් වෙන්නේ? ඇයි මේ ෆේල් වෙන්නේ? මතක තියාගන්න ඔය සයන්ස් කරන්නේ O level වල ඉන්න බ්‍රයිට්ම කේස් ටික. බ්‍රයිට්ම කේස් ටික මම කියන්නේ අනිත් අය මම මේ මෙව කරනවා නෙවෙයි. ආර්ට් කොමර්ස් කරන කට්ටිය මෙව කරනවා නෙවෙයි මම කියන්නේ. හරිද? ඒතර ඉන්න පුළුවන් බ්‍රයිට් කේසස් එහෙම නෑ කියන්නේ. නමුත් normally ගත්තොත් O level classes වල හිටපු බ්‍රයිට්ම කේස් ටික නැත්තම් most talented students ටික කට්ටිය තමයි math science කරන්නේ. අනිවාර්ය සිලෙක්ට් වෙන්නේ ඒගොල්ලෝ කරන්නේ ඒගොල්ලෝ. එහෙමනම් ඒ වගේ බ්‍රිලියන්ට් ළමයි සෙට් එකක් අරගෙන ඒකෙන් 50% ෆේල් වෙනවා කියන්නේ මොකද කේස් එක? අපි යන්නේ හොඳට තේරුම් ගන්න. ඒ කේස් එක තමයි පුතේ වෙන මුකුත්ම නෙවෙයි. වෙන මුකුත්ම නෙවෙයි. මම හැමදාම කියනවා වගේ අපි යන්නේ වැරදි රූට් එකේ. වැරදි රූට් එකේ පුතේ ඕගොල්ලෝ ඔච්චර ස්පීඩ් එකෙන් ගියත් හරියට එකට යන්න පුළුවන්ද? මම එක්සැම්පල් එකක් කියන්නම් ඕනනම් ඕගොල්ලන්ට යන්න ඕන නම් මාතර හරි කතරගම හරි හරිද? ඕගොල්ලෝ ගිහිල්ලා හරි යනවද අර මේ කුරුණෑගල දිහා ගිහිල්ලා හරිනවද? එහෙනම් මේ පැත්තට ගියොත් එහෙම මොනතරම් ස්පීඩ් එකෙන් මේ පැත්තට ගියත් ඕගොල්ලන්ට මාතර හරි කතරගමට හරි යන්න පුළුවන්. යන්න බෑනේ. ඒ වගේ තමයි අපි වැරදි රූට් එකේ මොන ස්පීඩ් එකෙන් ගියත් මොන තරම් හොඳ වෙහිකල් එකක ගියත් වැඩක් නැහැ. අපිට එන්ඩ් එකට යන්න බෑ. තේරුණා? ඒ වගේ තමයි අපේ මේ රූට් එක. අපි හරියට හදාගන්න. දැන් අපි දැක්ක අපි ඊයේ වර්ල්ඩ් කප් මැච් එක බලන්න අපි ලංකා ටීම් එක ගත්තොත් එහෙම ටීම් එකේ බෝලර්ස්ලා හිටියේ නෑනේ අත්‍තරම නේ. මේ නෑ වගේ ඉතින් අපි උන්ගේ ෆිසිකල් ස්ට්‍රෙන්ත් එකේ කිසිම නැහැ 0. ඔක්කොම ටික ඉන්ජර්. ඒකයි මම මේක ගිය පාරත් කිව්වා. හරිද? ස්පෝර්ට් කරන මිනිස්සෙක් වුණොත් පුතේ ස්පෝර්ට් කරන මිනිස්සෙක් හදාගන්න ඕනි ෆිසිකල් ස්ට්‍රෙන්ත් එක. තේරුණාද? ඒක තමයි ෆිසිකල් ස්ට්‍රෙන්ත් එක. ෆිසිකල් ස්ට්‍රෙන්ත් එක තියෙන්න ඕනේ ඒගොල්ලන්ට මොන මගුල කරන්නත්. හරිද? ඒගොල්ලන්ට ෆිසිකල් ස්ට්‍රෙන්ත් එක නැතුව කවදාවත් එතනින් උඩ එන්න බෑ. හරිද? ඒ වගේ තමයි ඔයා මේ ෆීල්ඩ් එක තෝරගත්තා නම් අනිවාර්යෙන් ඕගොල්ලන්ගේ මයින්ඩ් ස්ට්‍රෙන්ත් එක වැඩි කරගන්න. මොකද මේක මයින්ඩ් ගේම් එකක්. හොඳට මතක තියාගන්න මයින්ඩ් ගේම් එකක්. මයින්ඩ් ගේම් එක මයින්ඩ් ස්ට්‍රෙන්ත් එක ඕගොල්ලෝ හදාගන්න නැතුව ක්ලාසස් 100කට ගියත් වැඩක් නැහැ. අන්න ඒක මතක තියාගන්න. මම මේ ක්ලාස් ගන්න එපා කියනවා නේ. හොඳට මතක තියාගන්න ඕන තරම් ඕගොල්ලෝ යන්නේ කිසි ප්‍රශ්නයක් නැහැ. නමුත් මතක තියාගන්න මයින්ඩ් ස්ට්‍රෙන්ත් එක අපි වැඩි කරගන්න. හරිද? මයින්ඩ් ස්ට්‍රෙන්ත් එක කොහොමද අපි හදාගන්නේ? අන්න ඒක තමයි මම ඊළඟට මේ හදන්නේ ඕගොල්ලන්ගේ. හරිද? මම එක කිව්ව මම ඕගොල්ලන්ගේ ඕක දැන් හිමින් සැරේ මම මේක හදනවා කියලා. ඒක හදන්න නැතුව කොච්චර කරත් වැඩක් නෑ ඕගොල්ලන්ට. හැබැයි මම මේ කරන දේ ඕගොල්ලෝ යූස් කරන්න. හරිද? දැන් ඔන්ලයින් ක්ලාස් එකේ තියෙන එකම ඩිස්ඇඩ්වාන්ටේජ් එක තමයි පුතේ මට මෙතන ෆිසිකලි ඉන්නවා වගේ ඕගොල්ලන්ව බලන්න බෑ. ඒක නිසා හොඳට මතක තියාගන්න මම මේ කියන දේ ඕගොල්ලෝ යූස් කරන්න ඕන. මම ඒක හැම වෙලෙම කියන්නේ මට ඕගොල්ලන්ගේ නෝට්ස් එවන්න මට ඕගොල්ලන්ගේ මේ හදපු කැල්කියුලේෂන්ස් එවන්න. ඒ කැල්කියුලේෂන් එක හදපු විදිහෙන් මට බලන්න පුළුවන් ඕගොල්ලෝ හිතලා තියෙන විදිහ. මට අන්න ඒකයි ඕනේ. මම හැමෝටම කියන්නේ මට ආන්සර් ෂීට් එකත් එක්ක කැල්කියුලේෂන් ෂීට් එකත් එවන්න පුතේ. කැල්කියුලේෂන් ෂීට් එකත් එවන්න. මොකද කැල්කියුලේෂන් ෂීට් එක එවන එක තමයි ඕගොල්ලන්ට තියෙන හොඳම දේ. මොකද ඕගොල්ලෝ කරපු කැල්කියුලේෂන්ස් මට බලන්න පුළුවන්. සමහර වෙලාවට තිබ්බම සමහරුන්ට කියා දුන්නා මේ කැල්කියුලේෂන්ස් කරන විදිහ මේ කැල්කියුලේෂන් ෂීට්ස් එවන්න. හරිද? කැල්කියුලේෂන් ෂීට් එකේ මට බලන්න පුළුවන් ඕගොල්ලෝ කැල්කියුලේට් කරපු විදිහ. හරිද? හොඳට මතක තියාගන්න. අපි මයින්ඩ් එක ස්ට්‍රෙන්ත් එක හදන්නේ පුතේ. අපි කරන කැල්කියුලේෂන්ස් ගොඩක් දේවල් තනි කරම මයින්ඩ් එකෙන් කරන්න උත්සාහ කරන්න. මයින්ඩ් එකෙන් කරන්න try කරන්න. මොකද ඉනිෂියල් ඕගොල්ලෝ අනිවාර්යෙන් ඕගොල්ලන්ගේ මේ ක්වෙස්චන් එකක් වර්ධින්න පුළුවන් පොඩ්ඩක් වෙලා යන්න පුළුවන් මොන රිද්දක්ද මේ කියලා හිතෙන්න පුළුවන්. වදයක් වෙන්න පුළුවන්. නමුත් ඕගොල්ලෝ මේකට පොඩ්ඩක් try කරොත් අනිවාර්යෙන් මේ try කරන්න ඕගොල්ලන්ට හැදෙනවා. ඇත්තම කතන්දේ try කරන හැදෙනවා. මොකද මුල ඉඳලා මේක කරන්න ඕනේ පුතේ. පස්සේ මේක මයින්ඩ් ස්ට්‍රෙන්ත් එක වැඩි කරන්න අනම්මනම් කරන්නකොට ඕක කරන්න හම්බෙන්නේ නැහැ. හරිද? මතක තියාගන්න මුල ඉඳලම මේක පේන්න බලන්න ඕනේ. මොකද එහෙම වුණොත් තමයි අපිට අර කියන්නේ ක්වෙස්චන් එක දැක්ක ගමන් උඹට මීටර වෙනවා හදන්න ඕනේ විදිහ. හරිද? මීටර වෙනවා කියන දේ තියෙන්නේම මයින්ඩ් එකේනේ පුතේ. අපි සාමාන්‍යයෙන් ඕගොල්ලෝ කතා කරන්නේ මේ ක්වෙස්චන් ගාන මීටර උනේ නැහැ වනම් කතා කරන්නේ. මොකද මේ මීටර කියලා කියන්නේ? මීටර උනා කියලා කියන්නේ අපිට ඉවරේ ටක් ගාලා ඔලුවට ආවක් කියන්නේ. ඔලුවට එන්න නම් අපේ මයින්ඩ් එක ස්ට්‍රෙන්ත් වෙලා තියෙන්නේ මේ. අන්න එක තමයි තනි කර පුංචි දේවල් වුණත් රෆ් කැල්කියුලේෂන්ස් නැතුව මයින්ඩ් එක යූස් කරන්න. මයින්ඩ් එක යූස් කරලා ක්වෙස්චන් එක වැරදුනත් මුලදි කමන්න. හැබැයි අනිකරම හිතෙන් කරන්න. හරි. Okay. I will explain how I did this question. Then you can practice this one. Okay. Look at this. This length is 10. No? This length is 10. This length also 10. So I should add 10 squared plus 10 squared. No? 10 squared plus 10 squared means 2 times 10 squared. No? 2 times 10 squared. And I have to get the root of 2 times 10 squared. 2 times 10 squared. Therefore, 2 times 10 squared means the square root of 10 squared is equal to 10. Then the root of 2. The root of 2 is equal to root 2. We cannot get the value of root 2. No? So, that is how I did this question in my mind. No? I can write this one. AC squared is equal to 10 squared plus 10 squared. No? AC squared is equal to 10 squared plus 10 squared. So, AC squared is equal to 2 times 10 squared. 2 times 10 squared. That means AC should be equal to square root of 2 times 10 squared. 2 times 10 squared. This is a full square. This is a full square. Therefore, I can take the Square root of 10 square. 10 square. Square root of 10 square means 10. So I can take it out. So 10 times square root of 2. Square root of 2. 10 times square root of 2. Everyone, do you understand how I can calculate this one? Everyone, I need your response. Thank you. Thank you, Buddha. I did this calculation within my mind. Okay, you have to train this. You have to train this, Buddha. Therefore, the magnitude of AC vector, magnitude is represented using this symbol, okay? This symbol. The magnitude of AC vector is equal to 10 times root 2 Newton. 10 times root 2 Newton. We can write this one also. Magnitude of BC vector. Magnitude of BC vector is equal to 10 Newton. Therefore, we can determine the magnitude of any vector using the magnitude of a given vector. Okay. We can determine the magnitude of any vector using the magnitude of a given vector using our geometrical knowledge. Okay. Did you understand? Then write a topic. Determining magnitude of vectors using the magnitude of a given vector. Okay, right under the topic. Magnitude of a vector. Magnitude of a vector can be represented by a length of a line segment by the length of a line segment. If we are given the magnitude of a vector, in a vector system, and asked to find the magnitude of another vector, we can use the geometrical relationship between two vectors, to solve the problem. Okay. Look at the board, Pura, again. Everyone, look at the board. Okay, previously you have proposed a method to find AC vector. You have proposed a method, no? Now I have, now I will teach you another method to find BC and AC. Another method. Okay. In this case, it is very easy because ABC is a square. ABC is a square. Then you can see ABC equal BC. That is very easy. But this method is very important method. Okay. Look at this. Look at this. This is the usual method. This is the usual method, and this is the special method. Special method. Look at this. ABC. ABC is a rectangle, right angle triangle. ABC is a right angle triangle. So I can use trigonometric ratios to find BC and AC. I can use trigonometric ratios to find BC and AC. As this is a square, this angle should be equal to 45. This angle is equal to 45. So I can write tan 45. I can write, look at this. I can write trigonometric ratios to find BC and AC. BC and AC. How to do that? How to do that? Look at this. Everyone, listen very carefully. Listen very carefully. In this case, I have two data. Two data. What are those? First one is angle. Other one is adjacent side. Those are the two things I know. In this triangle, I know the angle and the adjacent side, Putano. Angle and the adjacent side. In ABC triangle, I know the angle and the adjacent side to that. So if we want to find the opposite side, what is the most appropriate trigonometric ratio? Can anyone propose me? What is the more? Very good, Puta. Because according to data, I know the angle and the adjacent side. I want to find the opposite side, adjacent side, and the angle. How to combine those three? From tan theta. So you have to define tan theta. You have to use the definition of tan theta to find x. So I can use ABC triangle. From that, I can write tan 45 is equal to BC over 10. Opposite side over adjacent side. Then you should remember the value of this, tan 45. So what is the value of tan 45? You should remember this one, tan 45. What is the value? Tell me. What's the value then? Trigonometric. 1. Very good. Tan 45 is equal to 1 Putta. 1. දැන් ඒට ගහලා තියාගත්තත් කමක් නැහැ මොකද මෙතනින් හරිය දෙන ගණන් වලට ඕක ඕනේ වෙනවා. Okay, so you should have clear memory about the trigonometric ratios. Okay, especially tan 30 60, not tan 30 30 60 45, such kind of thing. Okay, tan 45 is equal to 1, so 1 is equal to BC over 10. Then the length of BC is equal to 10. That means That means the magnitude of BC, the magnitude of BC vector is equal to 10 Newton. 10 Newton. 10 Newton. This is the first method. This is the method 1. This is the method 1. This is the method 2. Okay. You can note down this one as example. As example, note down this one. Okay, what about others? Have you noted down? Say right, no? Once you complete, please may give me a thumb. Then may I can understand. Okay. Shall I erase the board? Shall I erase the board? Okay. Thank you. Thank you, Uta. Okay. That is an example. Okay. Now you can use either method to solve this question. Maybe you can, maybe this will be a help for you. What about trigonometric values? Trigonometric values of special angles. 30, then 45, then 60. You should know more than that, but up to this level, those angles are enough. Okay. Tell me. Sine, cos, tan. Okay, if you don't remember, please write this one. Okay. I will let you know. Okay. What is the value of sine 30? What is the value of sine 30? Tell me. What is the value of sine 30? Sine 30. Sine 30. Sine 30. Half. Yes. It is equal to half. Cos 30. Cos 30. Root 3 over 2. Tan 30. Tan 30. Now you can divide both of them and get the value. 1 over root 3. 1 over root 3. Then 45. Sine 45 is 1 over root 2. Cos 45 is 1 over root 2. Then tan 45 is 1. Tan 45 is 1. 60. Sine 60 is root 3 over 2. Cos 60 is half. Tan 60 is root 3. It is easy to remember. It is easy to remember. Look at this. Sine 30 is equal cos 60. Sine 30 is equal cos 60. Cos 30 is equal sine 60. Sine 60. Okay. Tan 30 is 1 over root 3. Tan 60 is reciprocal of that one. Reciprocal of that one, that means root 3. So it is easy to remember. So if anyone want to copy this table, you can copy that table. Others go for these questions. Questions. I will give the questions. Okay. Okay, copy this table. I will give the questions. Once you copy down this table, please let me know. Thank you. What about others? Thank you, පුතා. Shall I erase this one? Okay. There are 3 questions, Puta. I will share the diagrams of 3 questions. Questions are like that. If I will share the if ABCD is a square, ABCD is a square, and the magnitude of AB vector is equal to 50 Newton. Find the magnitude of magnitudes of BC, BC, and AD vectors. Second one is a rectangle. ABCD is a rectangle. ABCD is a rectangle. If magnitude of AB is equal to 40 Newton, and magnitude of BC is equal to 30 Newton, find the magnitude of AC, find the magnitude of AC, BD, DC, AD. Then third one එක තමයි ඇත්තටම හොඳම ගාන. ABC is a equilateral. ABC is an equilateral triangle. And ACDE is a square. AC square. If AB is equal, AB vector is magnitude of AB's vector is equal 10 Newton, find the magnitude of following. Find the magnitudes of following. First one, BC and AC. BC vector and AC vector. Second thing, AE, DAD, BC. AE, ED, DC. That's it. AG and GC. Fourth one, EF and FD. EF, FD. BF and BG. BF and BG. Okay. You can see the diagrams in the screens, and I have given the question in the board. I will give you 15 minutes, okay? 15 minutes. Okay. Questions are mentioned in the board. Questions are mentioned in the board. BF and BG. BF, BF and BG. BF and BG. I can write this here. Done. BF and BG. BF and BG. Yes. Okay. Okay, I will put because some students are watching recordings. That's why I stop the sharing, because all these students should write the question now. Okay. You can take a screenshot of this question of this question now. Then I will share the diagrams. Okay. Okay. Those are the figures relevant to the question. the most important thing is you should remember the geometrical relationships, especially you have to have very good knowledge about triangles, then parallelograms, then circles, a little bit about circles, especially triangles and parallelograms. Okay. Sorry. Question should be 20 Newton. Okay. In question, your question is correct, Puta. In third diagram, it is given 20 Newton. It is given 20 Newton. So question should be corrected. The question should be corrected similar to the diagram. Diagram is correct. Diagram is correct. Once you complete the calculation, please take a photograph and send that to me. Send me as a WhatsApp, okay? Okay. Shall we check? Shall we check? There may be a question in third question, but others are not a difficult question. Okay. In the first question, we are given a square. We are given a square. From that square, we are given AB. AB. AB, it is equal to 50 Newton. AB, CD. Give me your answers, okay? So, we are asked to find BC, DC, and AD, magnitudes of other three sides. Magnitudes of other three sides. BC, DC, and AD. Tell me, what is the answers? Magnitude of BC, magnitude of BC. Magnitude of BC, how much? Now give me your answers in chat box. 50, good. As this is a square, this is equal to 50. 50 Newton. DC. DC also 50 Newton. DC is a length of side of this square. Side of this square. So it is also 50 Newton. AD also a side of this square. So it is also equal to 50 Newton. First one is very easy. Okay. The second one. The second one. The second one is a rectangle, puta. If you know the properties of rectangle, I think that is in your oral syllabus. Properties of rectangle. What are the properties of rectangle? Opposite sides are equal. Opposite sides are equal, and the diagonals, two diagonals are equal to each other. Okay, two diagonals are equal to each other. The square also has equal diagonals. Okay. If AB is 40, if AB is 40 Newton and BC is 30 Newton, we are asked to find the value of AC, DC, and AD. AC, DC, and AD. AC, DC, and AD. Tell me the magnitude of AC, magnitude of DC, magnitude of CB, sorry, AD. Look at this. You can see BC side. BC side is the opposite side to AD. So the length of BC should be equal to the length of BAD. Length of AD. So length of AD should be equal to the length of BC. Length of BC means magnitude of BC side. BC vector. BC vector. So that should be equal to 30 Newton. Look at this DC. DC and AB, those are the two opposite sides. Those are the two opposite sides. Look at this, AB and DC. As they are the opposite sides, the length of AB should be equal to the length of DC. Therefore, this should be equal to the length of AB. Length of AB means the magnitude of AB vector. Therefore, magnitude of DC vector should be equal to the magnitude of AB vector. So that is equal 40 Newton. How to find AC? AC. How to find AC? What is the value of AC? What is the value of AC? AC? What is the value of AC? Give me the answer in chat box. AC? To find AC, yeah, to find AC, we can use the Pythagoras theorem. Pythagoras theorem. AC squared is equal to AB squared plus BC squared. Square root of AB squared plus BC squared. That means that is equal to the square of 40 squared plus 30 squared. That means 50. That means 50. 50 Newton. 50 Newton. The third one. Shall I erase this one? Shall I erase? Okay. We are given two geometrical shapes. First one is a equilateral triangle. Second one is a square. But most important thing is sides of both square and equilateral triangle are equal. A, B, C, D, E, no? A, B, C, D, E, and this part. Now, you should well aware about the geometrical theorems. You are given this side is 20, this side is 20 Newton. The first thing we have to find BC and AC. It is easy. BC and AC, because as ABC is an equilateral triangle, ABC is an equilateral triangle. Equilateral triangle. That means AB equal BC equal AC. AB equal BC equal AC. Length are equals. That means the magnitude of AB vector should be equal to the magnitude of BC vector and magnitude of AC vector. All the magnitudes are equal. That means those should be equal to 20 Newton. As the length of equilateral triangles are, the sides of equilateral triangles are equal, that means the magnitude of each vector should be equal to each other. Did you understand this one? Everyone, I need to respond. Good. Others? Thank you. Okay, Buddha. Then I have found the value of AC. Value of AC is 20 Newton. Then ACDE is a square. As it is a square, all the four sides should have same length. Puta. Therefore, AC, the length of AC should be equal to length of DC, should be equal to length of ED. Yes, ED. ED and AE. Therefore, all the lengths are equal. That means the magnitude of each vector should be equal, and that should be equal to 20. The magnitude of AC vector should be equal to the magnitude of CD vector and magnitude of ED vector and magnitude of AE vector. That means all should be equal to 20 Newton. Did you get my point, everyone? The second part. Thank you, Buddha. This is the first part. This is the second part. That is easy. Third part. G here, no? G here. F here. AG. How to find AG? AG and GC. How to find AG and GC? Can anyone tell me? How to find AG and GC? What is the geometrical theorem you should apply to find AG and GC? AG. Yes. Yes. In this diagram, it is very clear, it is very clearly mentioned AG is a perpendicular to AC. AG is a perpendicular to AC. If it is a perpendicular, as this is an equilateral triangle, that perpendicular should be a bisector to this side. I think you remember this one. It is a perpendicular bisector to AC. AC as this is a equilateral triangle. That means AG is, the length of AG should be equal to the half of AC. Half of AC. Okay. The third part, I can write AG equal GC. AG equal GC, and it should be equal AC over 2 half of AC. So what is the reason? Because BG should be a perpendicular bisector of AC. Because BG is a perpendicular bisector of AC. Okay. Everyone, did you understand? Everyone, I need to respond. Thank you. Thank you, Buddha. Okay. That means, look at how I write this one. That means the magnitude of AG vector should be equal to the magnitude of GC vector, and that should be equal to the half of magnitude of AC vector. Half of magnitude of AC vector. I know the magnitude of AC vector, that is equal to 20. So this should be 20 Newton over 10. That means 10 Newton. 10 Newton. Everyone, did you get my point? Thank you. Then the same thing. As this is a perpendicular, and this is a bisector to AC, that means EF and FD also equal to each other, and those are half of ED. Half of ED. Okay. Therefore, fourth one. Then I can write EF is equal to FD, that is equal to half of ED. Half of ED. Because the same reason, as this is a bisector, and this is perpendicular to the ED, that means this should also be a GF, also GF should be a bisector to ED. I can write the reason. AG is equal GC and GF perpendicular to ED. GF perpendicular to ED. Therefore, GF should be a bisector to ED. bisector to ED. Okay. That means EF and FD. EF and FD. The magnitude of EF and FD. The magnitude of EF vector and FD vector should be equal to the magnitude of ED vector over 2. That means this should be equal to 10 Newton. Everyone, do you understand? Thank you. Others? Thank you. Okay. Okay, Buddha. Then I will clear this one. Then I need to find the fifth one, BF and BG. How to find that one? That is the most important part. How to find that one? How to find BG and GF? How to find? Good. How to find? There are several ways. You can use Pythagoras theorem because you know this one is 10. This one is 10, so you can use Pythagoras theorem. Okay? But the easiest way is not the easiest way. This angle is 60. This angle is 30. No? As this is a equilateral triangle, this angle is 60, this angle is 30, this angle is also 30, 60. So you can use trigonometric ratios. You can use trigonometric ratios instead of Pythagoras theorem to find the value of BG. Look at this, BG. If I consider sine 60, don't write every angles. Otherwise it will be confused. So I'm considering only this angle. So if I consider this angle, BG over 20 Newton is equal to sine 60. No? Opposite side over hypotenuse. Sine 60 is equal to opposite side. Opposite side means BG over hypotenuse. BG over hypotenuse 20. That means BG means equal 20 times sine 60. Sine 60 means 20 times sine 60. Sine 60 equal root 3 over 2. That means BG is equal to 10 times root 3. 10 times root 3, Buddha. That means BG vector, the magnitude of BG vector is equal 10 times root 3 Newton. 10 times root 3 Newton. Okay. BF. What is the value of BF? BF means BG plus GF. BF means BG plus GF. Now you know the value of BG. BF is equal BG plus GF. That means BG means now I have found that one, that is equal to 10 times root 3 plus GF. GF it is equal to 20, no? It is equal to 20. Both are parallel to each other, no? Both are parallel to each other. So this side is equal to this side. This side is equal to this side. That means 20. 20. You can stop here for, you can approximately equal root 3 as 1.7. 1.7 means 2.89. No? Therefore 1.7, that means 70. 17 plus 20 means 37 something. Okay, 37.32. Very good. You can simplify it by assuming root 3 is equal to 1.7. Then you can get the answers. Okay, did you understand, everyone? I need your response. Now we are going to complete today's lesson. Yes, thank you. Others? What about others? Thank you, Buddha. Thank you. Okay. Okay. Today we have discussed about how to determine the magnitude of a vector using a given magnitude. Okay, but that is very important thing, because in mechanics, this application will be, we have to use this application over and over time. Okay, therefore this may be a very important lesson. Okay. Okay, then we are going to complete today's lesson. Everyone, have a nice day. If you have any questions, please let me know. Okay. Okay. Welcome, Puta.